Section 1.3, question number 8. We want to solve for theta in the interval 0 to 2 pi. So 0 to 2 pi. Cosine 2 theta plus cosine 3 theta equals 0. We have to transform this equation in order to solve for theta. And because we have cosine 2 theta and cosine 3 theta, we need to have an observation. The argument is 2 theta and 3 theta. It will be hard to combine the cosine together as cosine of something equals a number because the argument 2 theta and 3 theta are different. However, the function is the same, cosine and cosine. So the technique to solve for this is to use these two identity. So cosine of negative x equals cosine of x. So this is an identity based on the graph of the cosine function, or cosine of pi minus x equal negative of cosine x. Now, why does this work? You think about the graph. So I draw the xy plane, and we have an angle. And that angle is, let's say, 3 theta. How do you get negative 3 theta, right? Or negative 3 theta, you go down. The reference angle is, you have to go down 3 theta degree, right? So right here is a reference angle 3 theta. But because you're going down, it's negative 3 theta. And you get the reference angle right here. From our knowledge, cosine, so cosine function is positive in Q1 and Q4, and negative in Q2 and Q3, okay? So we use this knowledge. And if you think about it this way, you go back 3 theta, and that's a reference angle, okay? And you get this line, and this line is a straight line from here to here. So these are reference angle. Because you're going back 3 theta from pi, if you want to calculate, okay, how big is this angle? You're talking about that angle as pi minus 3 theta. So this is the identity that we're basing on. So if we go back to the question, cosine of 2 theta plus cosine 3 theta equals 0. So we subtract cosine 3 theta on both sides. So we see, okay, cosine 2 theta equals negative cosine 3 theta. So now we use this identity to transform it into cosine of 2 theta equal cosine of pi minus 3 theta. Now, cosine of an angle equals cosine of another angle. There's only 2 possibilities. Number 1, they are the same angle. So 2 theta equals pi minus 3 theta. Another possibility is that, okay, so the cosine value is the same. It can only be referred as either they're the same angle or they're opposite of each other. So 2 theta will equal negative pi plus 3 theta. So those are our knowledge of the cosine function. Now, when you're solving for a trigonometry identity over an interval, or you solve it in general, you usually have to add 2k pi at the end. And the reason for that is that the cosine function is periodic with period 2 pi. So now you just need to solve these two. So from this trigonometry equation, we reduce it to just solving linear equation with the argument theta. So now we solve the first one. Okay, we add 3 theta on both sides. We find out 5 theta equals pi plus 2k pi. So theta will equals pi plus 2k pi over 5. So that is one of the solutions that include all the value. Okay, it's a general solution. The next one, we subtract 3 theta on both sides. We get negative theta equals negative pi plus 2k pi. And we divide both sides by negative 1. So theta will equals pi minus 2k pi. So this is a general solution. But the question is asking for particular solution between the interval 0 to 2 pi. So what we need to do is plug in value for k. So when k, so for the yellow equation, when k equals 0, what do we get? We get theta equals pi over 5. Okay, when k equals 1, we get 3 pi over 5. K equals 2, we get 5 pi over 5, which is just pi. K equals 3, we get 7 pi over 5. And when k equals 4, we get 9 pi over 5. Now we don't need to plug in k equals 5 because k equals 5 is bigger than 2 pi. So we stop right here. Now for the blue equation, when k equals 0, we get pi, which is the same right here. So you can examine, but you cannot plug in k equals 1 because that would be negative. When you plug in k equals negative 1, it's too big. Okay, so we stop right here. So we have 5 particular solutions that is inside this interval, and they are pi over 5, 3 pi over 5, pi, okay, 7 pi over 5, and 9 pi over 5.